So what we're going to do is to assemble Raspberry Pi 5 hat for NVMe PCIe. It uses a M.2 keyed connector. Now note that this is not the hat plus, which is the newer version that was released maybe a few days back of this video recording. I still haven't gotten my hands on it, but physical interface wise it looks slightly different. It comes below on the board. Probably might be careful about the OLDI cable on BeagleY-AI. But what we are going to do here is to use the original hat on Raspberry Pi 5 compatible BeagleY-AI. We are going to use a Kingston M2 SSD, which is 250 gig as our drive. One thing to keep in mind is that Raspberry Pi, unlike many other boards, in fact, the BeagleY-AI doesn't natively boot out of PCIe, at least in the configuration that we have put BeagleY-AI in. The boot mode switches are for SD card by default. So the way that we are booting the system is to boot from SD and then jump into the file system and use the kernel, use the configuration from the NVMe drive. Okay, now to start up, so multiple steps involved. The little flex cable that they come up with, make sure the blue is facing outside. All right, and the silver side goes in. Pull this little thingy up and then insert it all the way in, and once in, push it 2 hands down. Okay, so that way they're all connected properly. The silver side is in, the blue side is out. The cable moves like this. Now this is the best way to do it, because once you assemble the original hat, you won't have space to put in the cable. It's a bit of a hassle at that point. Okay, so the next step for us is to put the rest of the stuff together here. So I'm going to use my little blue thingy here. If I do find the Raspberry Hat Plus, I can probably do a video around that, how to hook that up, but this is more or less simple. So on the Pi hat, the original hat, just flip the connector up, move the blue cable in carefully, it's a little finicky little guy. And the blue is on top. Alright, we almost got it. There we go. You can actually see it. Make sure that the cable alignment is proper over here, and connect it down, and voila, that's it. Connection is done. And finally, the NVMe cable, NVMe card. Just plug it in here. And it clicks up, goes like this, and get the screw in place. Okay, now the initial test that I'm going to do, I'm just going to make sure that the NVMe card is working. I'm not going to do anything special, not actually boot up, but for that let's switch over to the serial port view. In this option, what we are going to do is we shall assume that you have a serial port, and we shall use the serial port option during boot to actually flash the NVMe. Now the second sequence will involve doing it using the GUI, which assumes that you don't have serial port. So for the moment, let's do the serial port option. Okay, now This assumes that the SD card has been flashed, booted, the standard stuff that you do, all that is complete. Okay, and it's a actually functioning SD card at this stage. Step 1, let's validate that the PCIe is working. Okay, so I'm going to switch on the board. As you can see, the red light glows and it's booting up. During the initial stage, you'll see that the blue light on the hat does not glow, and that will not glow until the NVMe is actually activated by PCI Linux driver. Now you can see it activated. Blue light starts glowing. All right, I have booted up. Right, and at this stage I am at Linux shell. Now do notice that the display will come up as well, and once the display is up, you can do the same thing on your terminal too. Either way is fine. So display, as you can notice, is coming up right now. So all we need to do is dmessage grep -ipcie, and you can see that NVMe is getting detected, blah blah blah, lspcie, and you can see that the non-volatile controller Kingston technology, which is what our SSD is about, that is enabled. Let us make sure. Yes, and you can see the device as well present there as well. So this is a quick check to make sure that PCIe, the way that we put the cables all together, the drive is working, etc. Okay, so I'm going to power off the device. So it has powered off completely. As you can see, the board is not enabled either. So I'm going to switch on the board again. All right, but this time we'll intercept it in the menu, the boot menu itself. So at this stage, you can see there's a transfer micro SD to NVMe option. We select that, and it'll take some time. Your disk image is typically around 5 to 10 gig image size, especially a freshly installed image. I would not suggest that you have installed while on the SD card additional images, additional packages, because that increases the size of the image that you'll have to copy over to NVMe. Anyway, so it is currently writing data to the NVMe. As you can see, look carefully, the NVMe LED, the blue LED is blinking, which shows activity. Okay, we have a lot of data to copy, in this case around 8 gig-ish, so it'll take a few minutes for the copy to complete out. We should be on the tail end of the copy operation. The disk image itself is around 5.8 gig to 6 gig, depending on how the disk image looks like. But as you saw, it takes around 15-16 minutes by the time it is done writing everything down. So after everything is put on the NVMe, it powers off, and at this point you're ready to go. So again, we are using the serial port, so I'm pressing the power on button to switch on. There's nothing much more you have to do, just switch it on and you'll see the menu has changed a little bit. So the boot menu now looks like, hey, I'm on NVMe mode, so everything is booting up in NVMe boot mode. So you should see the display up, the standard root file system, everything should be up and running. There you go, it's up. So boot firmware is still pointing at SD card, but the standard rootfs is on NVMe. Alright, that's on the SD card and serial port based flashing sequence. In this sequence, we are going to purely use the UI and do the same thing. We are going to assume that we don't have a serial port. So I'm going to switch on the board right now, and we are starting to capture data at this stage. I mean, boot up the device. Right, so UI should be starting up right now in a few seconds. There we go. UI is up. So as usual, what we do, we check whether NVMe is detected. So now that we are booted up, I've set up the terminal with the profile so that we can actually see it. My recording is is camera based. My HDMI capture device is not actually working for some reason. So let's try and see how well we can do it. So the very first step that we would do is to make sure that NVMe and PCI is working, and for that it's simple. Message grep -i PCIe, and you can see that PCI is happily getting detected, and all the functions are working. We can do the same with NVMe, and you can see that NVMe is also getting detected. Now this is good news. Let's make sure that the device is also there. So you can see the NVMe is 01, I mean partition, it's already pre-partitioned, but NVMe drive is already detected by Linux properly here. Now this is more or less what we need in terms of starting it up. Just to be sure, we can run the mount command line to make sure that we can see that MMC partition 2, which is the rootfs partition, is mounted on /MMC partition 1, which is where the boot partition is mounted on /boot firmware. Okay, now to flash using the UI is rather simple. So you just type sudo beagle-flasher-mv-rootfs-to-nvme, and that's it. And you have to be careful about what you're using. In rootfs to SDA is if you're using a USB hard disk drive, USB 3 for example. Rootfs to NVMe is the standard, which is to put it on our SSD. Okay, and that is more or less it. It will finish flashing. Again, it will take around the same long duration that it requires. 6 gig is around 16 minutes. Our default disk image is around 6 gigish. I would suggest that when you're running this script, make sure that nothing else is active, like Firefox or browser or some of the games that you're running across, etc. Make sure that nothing is active. You're just booted to the basic UI, and you're running the beagle-flasher command at that point. Okay, now I'll get back in a few minutes once the flashing routine has started. Right now it is going through the formatting of the partition. Now it has started copying from SD card to NVMe. Okay, as you can see here, we are rather pretty fast in our copy. We are approximately on the far end of it, but it did the copy in around 5 minutes or so, which was pretty interesting. Didn't expect that. Anyway, so it's copying the rest of the files in. Okay, and we are done. So in around 5 to 6 minutes, 6 gigabyte data was copied in. It's possible that my SD card is it's a different SD card that I'm using, but hopefully that's all we need to care. At this point, most of the activities are done, so you can run sudo power off, or you can use the UI option in selecting quit, power off, and selecting shutdown. Either one will work. And power off, and the board is switched off. Now at this stage, almost everything is done. All we have to do is power the platform back on, and voila, we'll have PCI boot. Again, let it start booting up. We just powered it on. There we go. So that's our little terminal. Mount, grab NVMe. As you can see, NVMe is your root partition now, and SD card is your /boot firmware, which is where we anyway boot up from. Now with this, your entire setup is with NVMe as your root file system. So you can do updates, you can do copies, and of course you have a large amount of storage media. In my case, I have a big one, 250 gig. But that's it. That's how you boot out of PCI. Not a big deal.